Rule 6, graphing points in the coordinate plane. Chapter 1, we use the coordinate plane to graph ordered pairs. So this should be reviewed to some extent. The coordinate plane, as you know, consists of your x-axis and your y-axis. Your point here at 0, 0, which is known as your, what do they call that? Your origin, where everything begins. So as we think about our, we have 4 quadrants. And we go with quadrant number 1 here, quadrant 2, quadrant 3, and quadrant 4, where we can find these different coordinates. If we think of our ordered pairs as being x comma y, in this first quadrant, we would have a positive x and a positive y coordinate. The second quadrant, a negative x, positive y. Third quadrant, they would both be negative. And fourth quadrant, we would have a positive x and a negative y value. Okay, so you could tell just by looking at them without even having to put them in the plane, based on what your x and y coordinates look like, being positive or negative, you'll be able to give an idea what quadrant they would fall in. Okay. It doesn't matter what order they come in, absolutely. So if we were graphing the point, we'll graph point A at 4, 2. It's called the origin because that's where we start with everything. We would go to 4 on our x-axis, and this works just like a number line. 4 is 1, 2, 3, 4, and from the 4, I would go to the positive 2. So my point would be right around there, and don't forget to label it with the capital letter A. If I were graphing point B, and it was something that was in the second quadrant, negative 3, 1, 2, 3, and a positive 1, be somewhere around there. If I were graphing point C at negative 4, negative 4, 1, 2, 3, 4, and 1, 2, 3, 4. We would find C somewhere in that neighborhood. And let's point D at 6, negative 2. 1, 2, 3, 4, 5, 6, negative 2, be about there, would be my point D. Are we limited to just one of the 4 quadrants anytime we graph a particular point? Are they always going to lie in quadrant 1, 2, 3, or 4? Or do I have other options? What about point E being at 4, 0? 1, 2, 3, 4, right here. What quadrant would that lie in? Close. You're right, it doesn't necessarily lie in a quadrant. It lies on your x-axis because it's actually on your x-axis right here. Same thing if we put point F at 0, negative 3. So 0, 1, 2, 3, point F will be located on your y-axis. Okay, so crash course on the coordinate plane. We've seen them before. You've seen them already this year that we've worked with these we graph some equations. We'll be graphing some more equations. In fact, we will look at certain equations, and they give us the domain, and we need to find the range, and we can graph them from there. For example, graph a function, example 3 on 207. Graph the function of y is equal to 2x minus 1 with the domain of -2, -1, 0, 1, and 2. Then identify the range. So this brings us back a little bit to take a look at y is equal to 2x minus 1. The domain and the range. The domain is going to basically be your x values. Your range are going to be your y values. So when they tell you, they want you to graph according to the equation given and the domain as -2, -1, 0, 1, and 2. Those are all the values you're going to find for your x, okay, for your value for x. What we then have to do is put these into the equation. So if my equation is 2 times x minus 1 is going to equal this y, notice I put -2 in for x, because that's what they told me to do. 2 times the -2 is -4. -4 minus 1. Do the same for -1. Plug in the -1 for x. -2 minus 1 becomes -3. Here's x. They tell me x to use 0 for x. 2 times 0 is 0. 0 minus 1. Now we get to the positives. 2 times 1 is 2. Minus 1. Positive 1. 4 minus 1 is 3. So what happens is we've got all these coordinates now. We can kind of view these as ordered pairs. So if we're going to set this all up and graph on an extremely abbreviated coordinate plane, and we set up the first point as -2 this way, -5, 1, 2, 3, 4. Our first point comes about there. The -1, -3, -1, -3 comes about there. 0, -1 is right there. 1, 1, right about there. And 2, 3, right about here. What happens to those dots? Should be in a line. We should be able to connect them, drawing arrows on them, which shows that it goes on in either direction forever and ever and ever, and that any point that falls along this line is also what? Yes? Yeah, solutions to the equation, right? Question. Yeah, and we usually go, yeah, absolutely. So we would say y equals 2x minus 1. I don't know if you remember doing this vaguely earlier in the year. Yeah. So if we see that, shouldn't be that unfamiliar to us if that comes across. Take a look at page 209. Numbers 3 to 12 give the coordinates of the point. So for number 3, where would I find point A? At what specific coordinates? Where would I find point A? Maria? Not 3, 3. Yes. Not 3, negative 3. Mark. 3, negative 2. How about B? How about B? Raven. So where specifically on the y-axis? Right, so 0, comma, negative 1. Nowhere on the x-axis did it go. It stayed right in line, and it went to negative 1 on the y-axis. Okay? What quadrant will we find number 14 in? Positive 5, positive 5. What quadrant do we have the positive, positive lined up that way? Okay. First quadrant. Very good. Let's take a look at page 210. How about number, why don't you do number 24 real quick? They want you to graph that equation, graph that function. Okay. Y is equal to a negative x plus 1. We're going to use the domain of negative 2, negative 1, 0, 1, and 2. Just a heads up, just in case I'm confident that you catch it on your own, what does this really mean here when they say negative x? What does it really mean? Yes? It really means like a negative 1 times whatever x is. You're going to add 1 to that. Okay? Give it a shot. Take a look and see what we have. I figured that if this is what it's really saying, then we might as well use that so we don't confuse the issue. So if it's negative 1 times x, negative times negative is a positive 2. Positive 2 plus 1. Negative times negative is a positive. Positive 1 plus 1. 0 plus 1. Now here, negative times positive is a negative 1. Negative 1 plus 1. Negative 2 plus 1. Negative 1. So that's what we should be using for our coordinates. You know what? Get above 3. So 1, 2, 3, 1, 2, 3, 1, 2, 3. So negative 2, 3. Negative 1, 2, 0, 1, 1, 0, 2, negative 1. All lines up this away. And we should have the y equals negative x plus 1. Did it flip-flop? Did you have them? Yeah. So you really have to pay attention to detail on those and make sure that you're doing what they ask of you. All this multiplying with negatives and positives and working with integers in general, adding them, subtracting them, it's just stuff that they expect that you're going to just nail and not have to think twice about it. Okay? For an assignment, I'm going to give you page 209, numbers 3 through 12, and 14 to 21. And then on page 210, let's do number 25.